So today we are going to be talking about solving systems of linear inequalities. So we spent the last week or so talking about how to solve systems of equations. So when there was an equal sign. Now we're going to be talking about solving a system where we both have inequality symbols. So less than, greater than or equal to, or less than or equal to. So our goals for this lesson, we want to determine whether an ordered pair is a solution, graph the solutions, identify solutions to linear inequalities, and interpret solutions. So in example 1, we have a given system of inequalities and we want to determine if each of them is a solution. So the way that we determine if an ordered pair is a solution is plug the ordered pair in to both inequalities. If you get two true statements it is a solution. So if you get one of the statements that is false, then that means it is not a solution. It has to work in both in order to be a solution. So you need two true statements is the key here. So let's start with part A, -2, -3. So we're going to plug that into the top equation. So x, which is -2, and then we're saying plus -3, and we're asking, is that greater than 2? So -2 plus -3 is -5. So -5 is not greater than 2. So because I have a false statement, I don't even need to try the second one because I know it's not going to work. And so that means that we say that this is not a solution. All right, so then I'm going to move on and try the next one. So 3, 2 here. So 3 plus 2, and I'm asking, is that greater than 2? Well, 3 plus 2 is 5, and 5 is greater than 2. So this one is true. That doesn't mean I say it's a solution yet. I have to check it in the other one as well. So 2 times 3 minus 2, and I want to know, is that greater than or equal to -5? So 2 times 3 is 6. 6 minus 2 is 4. 4 is indeed greater than or equal to -5. So I got two true statements, which means that this one is a solution. All right, so I want you to go ahead and try C and to check it in both inequalities. Remember, you need two true statements in order to say if it's a solution. If one of the statements is false, then that means you would choose not a solution. All right, so let's go ahead and check your answer. So x is 3, y is -1. So we do 3 plus -1, and we're asking, is that greater than 2? So 3 plus -1 is 2. 2 is not greater than 2 because remember, it can't be bigger than itself. It can only, oops, I put an extra S in there. It can only be greater than or equal to itself. So this first statement is false, which means I don't need to try the next one. I know that this is going to be not a solution because one of the statements is false. So not a solution there. All right, last one then. We're going to plug in -3, -2. So -3 plus 2, asking is that greater than 2? -3 plus 2 is -1. -1 is not greater than 2. So this one is also false. So my last one is also not a solution. All right, example 2. Solve the following system of inequalities and graph the solution set. So both of these inequalities are in standard form, which means we get to choose how we want to go about graphing them. So here, because this is just a plain y, I'm probably going to go ahead and just solve for y, because all I need to do is subtract the x on both sides, and that'll give me y greater than or equal to, and then I have -x and a +1, so -x plus 1. When I go to my second one, because it's got a coefficient in front, I probably would use the cover-up method here instead. So if I switch colors here, if I completely cover up my y term, remember we have to pretend like it's an equals, that just gives me an x and a 3. So x equals 3, so that means 3, 0 is going to be the x-intercept. When I go to do the y-intercept and I cover up the x term, I get -3y equals 3. So y is -1. So 0, -1 for my y-intercept on my second one. So since I'm already using the blue, I'm going to go ahead and graph the points for this one first. So remember back to activity 16. If you need to get out those notes, you can. But when we graph inequalities, first thing we do are to plot the points. So 3, 0 would be right here. And then 0, -1 would be right here. And I can see from those points that the slope is up 1 and right 3. So I could also go down 1 and left 3, and I know that would be in the same pattern. So I've got plenty of dots going across. Then I look at my symbol to determine if it should be solid or dashed. So remember, step 1, plot points. Step 2, solid or dashed. In this case, because it's a plain greater than, that means it's going to be dashed. So connect those points with a dashed line. And then I need to determine shading. So, as I said in activity 16, I generally pick the point 0, 0 unless it's on the boundary line. You cannot pick a point on the boundary line. So I pick 0, 0 and I plug it into the original inequality. So when I pick 0, 0 here, and I plug it in, I get 0 minus 3 times 0, and I'm asking, is that greater than 3? So 0 minus 3 times 0 is just 0, and 0 is not greater than 3. It's false. So that means that I should be shading the side where 0, 0 is not, because it was a false statement. So that means my shading should go over here. When I go back up to my maroon line here, which I put into slope-intercept form, its y-intercept is 0, 1, because my b was 1. My slope, when it's just a negative here, remember that that means that my slope is -1. So -1 over +1, or I could also do +1 over -1. But remember, negative slopes, the line should fall to the right. So down 1, right 1, down 1, right 1, down 1, right 1, so on and so forth, or up 1, left 1, up 1, left 1. Okay, I plotted the points. Then I look at my inequality symbol. This has the equals, so this one should be solid. Then I pick my test point. So I pick 0, 0. And I would just plug it into the original here. 0 plus 0 greater than or equal to 1. So 0 is not greater than or equal to 1, so that's also false. So again, I should not shade where 0, 0 is, but instead shade the other side. Now here's what's different. For a system, you need to find the overlap. So when we did a system of equations, what we did is we looked for the intersection points. It's kind of the same idea here, that we're looking for where the shadings intersect, and I've got double shading right over in this little triangle area. So this whole space, all of the points in there would be my solution. Now remember, this boundary line is dashed here, so it doesn't include those points on that boundary line, but it does include the points on the maroon boundary line there. So when it says graph the solution set, that just means make it very clear by shading it darker where my answer is. All right, example 3, write the system of inequalities that represents the graph below. So this is kind of a working backward one. So what I do is I notice that I've kind of got like a red and a blue. And so if I pick my red line, I can see, first of all, right away that it's dashed. So that's going to tell me that it's either, a less than or a greater than symbol, no equals. I also, when I look here, can see my y-intercept. And you can see that this says -2, which means this is 0, -1, because it was halfway. Now, I can also find another exact point where I can count the slope. So when I go right here, this point right there is at 1, because again, this big line is 2, so halfway there would be 1. So I've gone down 1, right 1. So the slope, down 1, right 1, gives me -1. So I've got a slope of -1, a y-intercept of -1. And generally, because the shading is below, that would lead me to guess that it should be a less than. So my first guess at this red inequality would be y less than, dashed, gave me the plain less than. Because its red shading was below, that's why I guessed the less instead of the greater than. And then it'd be -1x, so -x, and then b is -1, so I'd go right there. Now, you need to test it to make sure you chose the right symbol. If I pick 0, 0, I should get a false statement here. So if I pick 0, 0, I get 0 less than the opposite of 0 minus 1. 0 less than -1, which is indeed false, so I know I've chosen the right symbol. So now I'm going to go ahead and do the same thing for the blue inequality. So when I look at this line, this is also a dashed line. I see that my y-intercept is halfway between 2 and 4. So 0, 3 for my y-intercept. And then I want to count out to find my slope. So let's see if I can find one. Here's one that's on an exact point right there. So let's do my connections to find my rise and run. Okay, so here's my rise. Here's my run. So my rise, this is 1 unit. Here's 2 more, so that's 3. Here's another 1, so that's 4. So slope has a rise of 4 and a run of 2, which gives me a slope of 2. So now I need to decide, okay, which symbol should I use? I now know that because the slope is 2, that it should be 2x. Since the y-intercept is 3, and that's positive, it should be plus 3. So now I need to decide, should I use the greater than symbol here, or should I use the less than symbol there? So that's what I want you to think about next. So go ahead, you can test a point if you want, but decide, should it go this way and be a greater than, or should it go this way and be a less than for the blue? All right, so if I'm looking at this, the process of thinking that I would go through is I would look at the picture and I would say that it looks like the shading is above the boundary line. So because it looks like it's above, I'm going to guess a greater than symbol, and then I'm going to test it. So when I pick 0, 0, which is not in the shaded blue area, so I should get a false statement when I plug in 0. So 2 times 0 is 0, 0 plus 3 is 3, 0 is not greater than 3. I do get a false statement, which means that I have chosen correctly. So here is my final answer. This is the system of inequalities that I see in this picture. Now again, it didn't ask anything about the solution, but the solution set would be over in this almost purple looking area because that's where the red and the blue intersect. All right, so determine the solutions to the systems of inequalities by graphing. So this is very similar to what we had in example 2. So we're going to graph these. Notice that this guy is already in slope-intercept form for us. So I can see just by looking at it, okay, my slope is 1/2, that's my m. This is my b at 2. So y-intercept at 2, slope of 1/2, up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. And because it's a plain greater than, going to connect it with a dashed or dotted line. When I pick 0, 0, I get 0 is greater than 1/2 times 0 plus 2. 0 is not greater than 2, that's false. So we should not be shading where 0, 0 is. So that should make sense because greater than generally means above. So we're shading above the boundary line. So now when I go back over here and I'm going to graph this guy, if I try to do x-intercept, it's going to be off the page because it's going to be at 8. So on this one, I'm probably just going to go ahead and solve for y. So subtract x first. It gives me negative 2y greater than negative x plus 8. And then I need to divide by negative 2. Now when I do this, that really annoying noise that I make should be going off in your head. That's because we're dividing by a negative number, which means I need to flip the symbol. So this was a greater than, I flip it to a less than. Negative divided by a negative is a positive, so positive 1/2 x. This is positive 8 divided by negative 2, which is going to give me a negative 4. So I have a y-intercept of negative 4 with a slope of 1/2, so up 1, right 2, up 1, right 2, or down 1, left 2. This should also be dashed. And when I pick 0, 0, and plug it in. I have 0 is less than 1/2 times 0 minus 4. 0 less than -4 is false, which means I should not shade where the origin is. I should shade here. Now, remember what I said in that second example. The answer is the overlap of the two shadings, which I, made darker over here. In this one, we could see where they overlapped. In this case, this shading doesn't overlap at all. And they never will because these lines are parallel. They're never going to intersect, which means that this one, because there is no overlap, that means that the answer here to this system is no solution because there is no overlap. So if you thought you got rid of those no solutions when we moved to inequalities, sorry about your luck there. All right, so now looking at example 4, part B. So I'm going to get y alone here by subtracting 3x on both sides. So that gives me y less than -3x plus 3. And so that's a y-intercept of 3 and a slope of -3, which means down 3, right 1, down 3, right 1. So on this one, it's a plain less than. So again, I should have a dashed boundary line here. When I plug in 0, 0, that gives me 0 is less than -3 times 0 plus 3. So 0 less than 3, this one is true. So I should shade where 0, 0 is. So my maroon shading should be all of the area over here. Now I'll go back to my blue. This one, again, very easy to get y alone, so I'll do that first. So y greater than or equal to -3x minus 2. So -2 is my y-intercept. -3 is my slope again, so down 3, right 1. Or up 3, left 1. Up 3, left 1. This should be a solid boundary line. And when I plug in 0, 0, I get 0 greater than or equal to -3 times 0 minus 2. So that gives me 0 greater than or equal to -2, which is true. So 0, 0 should get shaded, which means everything over here would get shaded. So the overlap of the shading would be right in between. So trying to shade it darker so that we can see that overlap being the solution. All right, last example. Matthew bought used books from a website. The paperbacks cost $2 each, and the hardcovers cost $3 each. He spent no more than $90 on the books, and he bought no more than 35 books. Rate a system of inequalities to represent the situation. State what the variables represent. So, stating what the variables represent, I'm going to let X be the number of paperbacks and Y be the number of hardcovers. So, first, second sentence really, I'm going to turn into an inequality. The paperbacks cost $2 each, so that's 2 times X, the number of paperbacks, and the hardcovers cost $3 each. He spent no more than $90. So plus 3, which is the cost of hardcovers, times the number of hardcovers. It says no more than, so that means $90 or less. So less than or equal to 90. So this inequality deals with the money. The last part of the sentence, this one, he bought no more than 35 books. This is only dealing with the number of books. You are not using the money at all. So what I want you to do next is to write what that second inequality should be. So using only the number of books, which are X and Y, write the inequality that means he bought no more than 35 books. All right, so again, we're only talking about the number of books here. No more than 35 means the total is no more than 35. So total number of books would be represented by X plus Y. No more than 35 means less than or equal to 35. So these are my two inequalities. Now I want to graph them. So when I look at this inequality and I use the cover-up method, I get both of them because it's just a plain X and a plain Y. When I have the X plus Y less than or equal to 35, if I do the cover-up method, I end up with 35, 0 for my X-intercept and 0, 35 for my Y-intercept. So if this is counting 20s, that means that each one is 5, 5, 10, 15, 20, 25, 30, 35. So here's 0, 35. Here's 35, 0. And so I know that it should be a solid line, and less than or equal to generally means underneath, but I can test 0, 0 if I want. 0 plus 0 is less than 35, so that means underneath here would be the shading. Then when I go to look at my blue inequality and I do the cover-up method, so 2x plus 3y less than or equal to 90, so I end up with 2x equals 90, so that means x is 45, so 45, 0 for the x-intercept. Then when I cover up the x's, I get 3y equals 90, so y equals 30, so 0, 30 for the y-intercept. So 0, 30 would be right here, and 45, 0 would be right here. And if I could use a straight edge, I would. I apologize if it's not extremely straight here. Oh, that wasn't terrible. And shading, again, if I plug in 0, 0 plus 0 is less than or equal to 90. So that means the shading should be underneath the blue line as well. So the overlap, let me use that teal again. That seemed to work a little bit better than the black. The overlap should be everything in here, because it needs to be in the first quadrant, because otherwise it wouldn't make sense in the real life situation. Can't buy a negative number of paperbacks or hardcovers. All right, so what does the shaded region represent? The shaded region represents the solutions for possible numbers of paperbacks and hardcovers that can be bought. So can he purchase 20 paperbacks and 15 hardcovers? Well, we said X was paperbacks, so let's just label our axes here. This is number of paperbacks, and this axis is number of hardcovers. So 20 paperbacks, 15 hardcovers. 20 paperbacks would be right here. 15 hardcovers would be right here. And so it looks like, in this case, that this would be a yes, because it's just barely in the shaded region, but we would say yes. Yes, because the ordered pair (20, 15) is in the shaded region. So the overlap, the teal part, which it is. All right, last question. Can he purchase 10 paperback books? So 5, 10 would be here, and 25 hardcover books. So look at that. And when I look on the graph, this one is super close. When I go to X is 10 and Y is 25, it's like right here. And because I didn't use a straight edge, it's really hard to tell. It looks like it's outside this line, but it definitely looks like it's outside of the teal. So it looks like it might be on the maroon line, but not in the teal line. Here's how you can be sure. If you plug it into these inequalities, remember it would have to give you two true statements. If I plug in 10 for X and 25 for Y, I get 20 plus 75, which is 95. So no, it doesn't satisfy the first one. So you can say no, and you can either say because 10, 25 is not in the shaded region, or you could also say no because the ordered pair 10, 25 does not give a true statement in the inequalities. Those would both always be legitimate explanations for why it was a yes or a no. So hopefully you can see how we make those connections to real life with our inequalities here.